All right, guys, a few quick notes on behavior of gases. I think these notes are on page 6 in your packet. If you want to just fill in those blanks, it'll be really quick, and I will do some demos and explain this in the room too on Monday or whenever I see you again. So, quick review, temperature measures how fast particles are moving. So remember, as particles move faster, there's more friction, it increases heat. So the higher the temperature something has, the faster the molecules are moving. This will be important for what we're going to talk about. Think of a thermometer as a speedometer. It's actually measuring the speed of the particles. So when they're faster, they're going to zip up this further. They have more energy, and you get a higher reading on your temperature. Pressure is the other part of our gas law rule, and that is the amount of force per area. So if you want to talk about pressure, you have to think about how fast those molecules are moving and then how much area they have to push on. And the reason we have pressure is those particles, which is about a gas. We are talking about a gas. Sorry, itchy nose. Those particles, because they're moving so fast, are trying to get out. They just fill their container. They don't know there's a wall there. So as those gases zip around, they just hit the walls of the container, and that is what causes pressure. So think about this. If I blow up this balloon, okay, and I tie it, hang on just a second, there is pressure inside this balloon. If I decrease the volume of the balloon, so I'm making the volume smaller, what happens to the pressure? And if I increase the volume, what happens to the pressure? So we already know this happens, we just have to define it and put some rules to it. So a person named Boyle, I honestly can't remember his first name, came up with a law that describes the relationship between pressure and volume. And he said, as volume decreases, so I make this balloon volume smaller, I'm going to increase the pressure inside that balloon. So if you think about it, we know what happens. You make your balloon smaller, the pressure goes up. This only works if temperature stays constant. So you have to keep the temperature the same because temperature will increase the energy. But if that stays the same and you make this smaller, pressure goes up. That is because there are more collisions. So the rule for Boyle is when temperature stays constant, volume goes down and pressure goes up. I'll show you a trick for remembering that. We call this type of relationship inverse or inversely proportional. And my trick for remembering that is I say, oh boy. I'll show you that in a minute. So I want you to think about this. How does pressure affect boiling point? So pressure is, if I had some liquid and I wanted to boil it. So pretend my cup here is full of liquid that's trying to boil. Boil water in this cup. If I push on it really hard with a lot of air pressure, it's going to be harder for those molecules to jump out as a gas. So if you increase the pressure on that liquid, I increase air pressure, I will need more energy to get that liquid to boil. So think about that. We will talk about it in class. Oops, sorry about that. Okay, here's another picture of increasing pressure. So gases are flying around like crazy people. If they have a lot of room, they're not going to hit the sides as often. If they don't have as much room, so you increase pressure, they are going to just hit the sides of that container faster and faster, and it increases that. Okay, so, whoops, wrong way. Quick review on temperature. I'm going to speed through that. The other gas law we're going to talk about is called Charles' law, and he made a law that shows the relationship of temperature and volume. And again, we already know this. Think about a hot air balloon. When that hot air balloon starts to deflate, they fire up the flame underneath that balloon. That increases the temperature of the air in that balloon and it gets bigger. So as you increase temperature, you're also going to increase volume. Again, we have to keep one of these parts constant, so we have to keep pressure constant all the time. So again, as temperature increases, those particles move faster because they have more energy, so they're flying around. So that means they can take up more space, so it's going to make that balloon bigger. I'll show you a balloon in boiling water later, but Charles' law is about TV. I'm going to show you a trick there in a minute, and T and V both go up because Charles thinks he's really cool. So thumbs up to Charles, TV both goes up. Here's another picture of it. If I have boiling water or water here with a little bit of heat, those molecules will move around. As I increase the heat, they have more energy, they start moving faster, and they increase the volume of the space that they are in. There are a couple other gas laws that you will learn as you go through. I'm going to skip over that for time. We'll talk about them later. And then we can combine all of these. The volume and pressure of gas are connected. Both are affected by temperature. So if you combine Charles' law, we can say that if temperature increases, volume increases, and pressure increases. All right, here is my trick to remember this. Charles in Charge was a TV show when I was a kid, probably elementary school, and everybody was in love with Charles, right? He's super hot, and he was on TV. So Charles was on TV. He thinks he's really hot, so he's going to give himself 2 thumbs up. So Charles' law, if temperature goes up, volume goes up. The other way I remember this, Charles thinks he's so hot that when he walks around, he walks like this and takes up a lot of volume. So Charles is on TV. He thinks he's hot, 2 thumbs up. And because he's hot, he's going to walk woohoo with a lot of swag like that. Okay, my law or my trick for remembering Boyle's law is Star Wars. So as we decrease the volume, these guys are in the trash compactor if you saw this Star Wars episode. But you can see them. Those walls are decreasing in volume, and so they're pushing on the edge. So as you decrease volume, you increase pressure because you're saying, oh boy, and you want to get out. All right, we'll talk about all this in class, and see you soon.